Okay, so in our last video, we took DNAC as far as we could, as far as configuration goes, to the point where we're now needing to add our network devices to it and finish off the SDA. So again, I mentioned previously in the first video when we went over the architecture here that, this is a full mesh today of switches and, connectivity. And we obviously don't want that, nor do we need that. So we need to make sure that these two links between 2 and 3 are down, and we need to make sure that these two links between 2 in the fusion and 3 in the fusion are all down. And while this lab is still in a build process, these links here aren't even plugged in yet, so we don't have to worry about those, but these definitely are. So if I jump over to my switches, all I've done here thus far is given them a host name, and that was literally just so I could look at CDP and see what was connected to what. So on Lab 01, per our design here, we've got 47 and 48 going to our Fusion router. We have 1, 2, 3, and 4 going to our O3 and O2 switches. On our O2 switch, we have our connectivity to O1 and our connectivity to O3, and this is what needs to get shut down here. So interface range gigabit 1047 and 48 shut. I'll write that. And then of course over on number 3 here, now that we shut those down, we'll go ahead and shut them here too, but obviously just links 3 and 4 go to our O1 switch. Interface range 1047 and 48. So now this piece of the connectivity was probably the most difficult for me to wrap my head around as I started building this, right? So typically, obviously DNAC doesn't live local here, right? It is external to this set of switches. It lives up in here, call it a cloud if you will, call it a data center, whatever. And in order to add this device, we need some sort of IP connectivity to DNA Center. Now, when it's done and we build our transit on these links, they have to be a trunk, right? Because those VNs that we built, we have our Field of Dreams VN that is going to have VLANs assigned to it that it's going to need to peer to this Fusion transit, as well as the infrastructure, the default needs to be able to peer to this Fusion. So we will have multiple BGP adjacencies off of multiple VRFs from this border to the Fusion. And if I was to go in and create just layer 3 links on these ports, as soon as I added the device and tried to push the config, obviously I'm going to cut the device off from the network altogether. So we have to be careful about what we do. I took the config that we're going to use on these switches directly from the Cisco LAN automation. So I previously took a couple of switches, connected them up, and used LAN automation to create the configuration. And then I harvested that config and looked at it and figured out, all right, this is how obviously Cisco would recommend to build an underlay manually. So the config that we'll put in as we talk through it, again, is what DNA Center would push if you used it to build all of this via LAN automation. So if we go back to our switch, we're going to be on O1, and I will start pasting in this config and we'll kind of talk through it here. And wouldn't you know it, I already got a typo in my config, so I misspelled the word logarithm. So let's try that again and make sure we don't have any issues there. There we go. So all we're doing here, obviously, we create our enable secret, we turn on AAA new model, IP routing, IP multicast routing. We set our domain name lookup to loopback 0, system MTU to 9100, and then a username, DNAC, which, of course, as I mentioned earlier, matches what I've got in Active Directory with the same password. So that way, when we provision this device, it'll just flip over and start authenticating to Active Directory and continue to be successful, assuming our policy on ICE is set up right. The next thing we will blow in here is the loopback interface. So this will be the interface that we add when we add this device to DNAC. We will point it at this IP address. So this is the IP that we need connectivity to, routability from DNAC in order to bring this up. The next two things will be the interfaces going to the Fusion transit. And again, they are just a trunk and a random IP address. So if you notice port 48 here, I made this no switch port. I'm doing a point-to-point link. Ultimately, in this scenario where I've got two links to my Fusion, I'm going to initially configure this one in SDA. Once the network flips over and my BGP connection comes up across this link, I will then default this interface, get rid of a static route we're going to put in here in a minute, and go back into DNAC and configure this as a secondary transit. So I'm essentially walking this across so that I never lose connectivity to this loopback interface. So again, this is probably the most confusing part of it to me. This is what I fought to wrap my head around for quite a while, and now kind of understand that, hey, yeah, in a normal environment, we're only going to have, two borders or whatever that we have to actually, go through this process with up front to get things up and online. So the rest of our config, we will paste in some additional configuration here and talk about it. So here, this is going to be our underlay. We have ports 1, 2, 3, and 4. These are all routed ports, and these ports go directly to our O2 and O3 switches. So we are using WAC 31s, 2, 4, 6, and 8. And on the other switches, obviously 3, 5, 7, and 9, when we paste those in. All of this config, again, as I mentioned earlier, comes from the LAN automation config. So everything that you see here is stuff that LAN automation would put on this. By default, it uses ISIS as the routed protocol for the underlay, which is what we will paste in next. So the configuration for ISIS is here. I updated this net. The LAN automation does something, right? Has some algorithm that creates this. In mine, I essentially inserted the switch's loopback IP to the net. So you can see 10, 197, 0, 254. We'll see that methodology moved through to the rest of the switches as well here. And then the last bit of data here is more basic stuff. We set up our RP for multicast, register that for loopback 0. Here's my default route this is what we will eventually configure on the Fusion for port 48, pointing back this way as well, so that we can ping and get data off of that loopback interface up to DNAC. netconf yang we need turned on, and then in order to authenticate via netconf yang, we have to authenticate locally. My v3 credentials, you'll notice this is going to match what we created in DNAC, and that's about it here. So if we jump over to my Fusion, which is here, and we log in, oops, here what we're going to look at is creating the other side of the routed link that I stole for port 48. So here, if we do a show CDP neighbors, we should see lab 2 3850.01 on ports 47 and 48. This should be empty. And here we are going to assign this the other side of that network. All right, more stale config. So I found some static routes that were in here, and that's what was causing our issue, I think. There we go. So now that that's up, I should be able to ping my switch at 200, and I can. So we'll write that config. The next thing I need to do here is a static route to my loopback 10.197.0.254, 255, 255, 255, 255 to 10.197.0.201, 200. So that's going to route my loopback down to the switch here. This switch here should have a default gateway pointing back at the Fusion router, and at that point I should have internet access. So now I know that this switch is reachable and can get in and out of the network. Source loopback 0, there we have it. So we know that's good. Now if we go over to the second switch, what we should see here is, again, we only have connectivity to our Fusion, or our border router, not our Fusion, on ports 1 and 2, and the initial config is going to be the same as the other switch. The only difference here, of course, is my router ID is, or my loopback 0 is 253, not 254. Ports 1 and 2 have the opposite side of that WAC 31, 3 and 4, or 3 and 5, excuse me, 4 is on the other side. Once we throw in the ISIS config, we should see adjacencies come up, and there they are. And then the rest of our config here is the same, other than the fact that the loopback, or excuse me, the RP is the core, or the border. So here we see our neighbors are up, and then we'll go over to the third switch, and again the only change here is our loopback is now 252 instead of 253 or 254. again, our interfaces 7 and 9, so they are the other side of the connection. And again, when we bring up ISIS here, we should see those adjacencies form, and the rest of our config is the same. So now show ISIS neighbors. Well, we do have something wrong here. Okay, I started troubleshooting and just realized it took a second. So here our adjacencies are up now. If we go back over to our border and do the show ISIS neighbors, we should have 4. There we have them. So that is pretty much it. That is an underlay. Based on LAN automation, we have an ISIS routed network for an underlay. And at this point, we should be able to start configuring some of our fabric, or bring these devices into DNAC and start configuring some of our fabric. Now, what you'll notice here is that on the Fusion, the only loopback I've made available at this point is the one for my primary switch, my border node. So we're seeing this default gateway to our switches downstream. However, we shouldn't be able to ping anywhere, right? There's no return route. No matter what I source from on 2 and 3, we don't have any return routes yet. So what we're looking at here is, once I bring up the border control plane node in SDA and configure my BGP transit to the Fusion, it will start advertising these loopback interfaces out. So if you'll notice here, I do a show IP route on my border, it knows and is learning about 252 and 253 via those links, but it's not passing them on yet via, any redistribution into BGP, so that my Fusion knows how to get there. So there's just no return route yet. Once we bring up those transits, it will fix that. So at this point, we will jump over to my DNAC, which I've probably been logged out of, maybe. I don't know what's going on here. Yeah. So now if we go to provision inventory, add a device, 10.197.0.254 is our switch. And again, here is where previously we created those credentials. Now I can select this as a global credential. If I move over to V3, select our credential we created there, and then the last one, netconf, when you click the down arrow, this has to be port 830. When we're done with that, I can hit validate, and assuming everything is sound, these should all go to green check marks, and we should verify that everything is reachable. And there we have it. So all 3 are green. I can hit add here. Now, once this goes away, I'm going to pause the video for a minute, because it does take some time for DNAC to ingest this switch and synchronize it and all that kind of fun stuff. So I'll pause here, and when it gets done, I'll be back. Okay, that finished up. So now we can see Lab 2 3850.01 was added. We're loopback address. It found all sorts of information about the switch, but what did it do to the switch, right? If we look back here on the command line or the console, we can see that, it logged in a bunch of time, authenticated via netconf, so on and so forth. Did it push any config? At that point, it should not have, right? All we're doing is adding it. The only thing in this scenario that it may have done, no, it didn't. So that's all we got. All it did was added it, verified that it could get to it, and away we go. So nothing changed there. If we go back over to DNAC, the very first thing we need to do, of course, is tell this switch where it belongs. So we're going to assign it to a site. And of course, in this case, it is going to go on the Field of Dreams. And I'm assigning it to the floor in this scenario. I guess, if you were in a production environment, you'd assign your devices to the floor that they live on. I guess this is going to be home plate at the Field of Dreams. We go through the process here, and what we'll see now is once it gets done chewing on this, it's going to spit us back some configuration as to what it's going to push to the device when we do this. Okay, and that got done. So it shows us what the current running config is, and then it shows us what it's going to do, what it's going to deploy. So we can kind of see here it sets the syslog hosts and their source interfaces, some SNMP data. The loopback sets the client source interface to the loopback, creates a certificate for it and DNAC, and then it assigns the device tracking policy to all of the relevant interfaces, and that's about it. So here we'll go ahead and deploy that, and that takes some time. Now we'll find ourselves here a lot as we do things with DNAC. I don't like to push it. I could, move on right now and start trying to do other things, but in this scenario, right, we can come into this tasks and we can see the tasks that are running and when they finish and when it's done. So over here we can see DNAC started logging in, and we'll actually be able to see as it starts to push this configuration what it's pushing and what it's doing. Okay, I paused the video. That obviously took some time, but we can kind of see here in the console a little bit about what happened with the logging host. We created the certificate. DNAC's logging back in again here, but it pushed all of that config. And at this point, if we go back over to DNAC, we can see that finished successfully. And now over here, we're done with that. If I refresh this, we'll see that it last updated a few seconds ago, and we should be good to go. So the next thing we're going to do is provision this device. So actions, provision device. We already have the site assignment. We could have done this all in one shot, but here we are. And then again, it's going to tell us that, hey, I'm going to set all of these settings, right? We're pointing this at TACAX, we're pointing this at radius, we're setting our domain name and our DNS server, so on and so forth. Now, the problem we're going to have here is we haven't configured ICE for TACAX yet. So we need to go verify that that is sane before we push this. Otherwise, what's going to happen is it's going to push this config, and if ICE isn't set up to authenticate once DNAC starts trying to log into the device is going to try to authenticate it via TACAX, via ICE, and that's going to fail. So if we go back over to ICE here and get logged in, we are going to go, one other thing I guess I didn't mention, right? If I go into administration network devices, I didn't create this. So one of the pieces of integration in DNAC and ICE is when you configure that, it is actually going to automatically push and create this network device. So in larger environments where maybe you have policies tied to specific device locations and types, it of course is not going to know what location or type you are keying in on a policy. So you would have to come in here and manually update those pieces of information. But for us, it's here. That is good. We didn't have to come manually add that network device to ICE. It did it for us automatically. And now we want to go fix up our device administration. So here I've just got a default TACAX policy set. I'll use the default here. And down here, obviously, deny all is our only option right now. So here we're going to say priv 15. Add a new command set. That simply says allow all. Permit any command not listed below. Choose that here. And then we need to add a new shell profile. I'll call this priv 15. Set both of these to 15. Whoops. Set that. My condition, if I look, I am going to point this at an Active Directory group. But yet again, we have yet to tie ICE to Active Directory. So the first thing I'm going to do is I'm just going to throw something in here just so I don't lose the settings that I saved here. And then we've got to go tie ICE to Active Directory for this. So here, administration, external identity sources, Active Directory, add, join point name, lab2, lab2.local, submit. Found my domain controller, says would you like to join the ICE nodes to Active Directory. Good, we're happy there. Then we need to choose what groups we're going to use. If I retrieve them all, did I previously build a Cisco admins group here? Don't believe I did. So we need a user and a group in Active Directory. Not sure why my start bar is covering this up, but directory users and computers. Yep, so we don't even have a DNAC user or a group. So what I'll do here is create a user. Where did it go? DNAC, DNAC. Whoops, DNAC. In here, this is essentially going to be a service account for the login. This password is going to match exactly what I set on the device itself. So the local credentials to the device and this account are the same. And I'm going to create a new group called Cisco Admins. I'm going to add DNAC to that group. Whoops, that's Cisco Admins. And now when I go back over to ICE, retrieve these groups, we are going to add a few groups here. First, we're going to add the domain users as users. We should have domain computers. Oops, that's controllers. And then we should have our Cisco group in here somewhere. Just going to add that first. I still told that one. Delete that group. Do a filter on it. There it is. Okay, so we can save that. Now that we've added these here, When we go back to our device admin policy, instead of identity group name, notice now we have our Active Directory external groups. And I think we got here too fast because normally this does a drop down. So if I cancel out of here, come back in, hopefully those groups will be available. There we go. So Cisco admins, use save. So now we've basically wrote a policy that said, hey, if a device tries to authenticate from essentially any switch, right? We're not filtering on who tries to authenticate. So again, it's lab, bad practice in the real world, but and the user who's authenticating is part of this group, return these results and make it so that they can log in. So back over here, we'll say next, apply, next, and we'll let this preview generate. And here is our config. So we switch authentication, convert to new style, push an access list, our AAA configurations, our radius server, and that's that. So deploy this. And if we come back over here, we refresh. And we can see that job is running. And now we can see that finished successfully. If we come back over here to our switch, we can see it did push a bunch of data. Let's log in. We've got our AAA. But here's something that's interesting that I noticed. This is using radius rather than TACX to log in. So that means we must have configured something improperly, or I missed it on ICE. Or excuse me, on DNAC. So let's go look at that. That would be underneath our network settings. This is set for TACX, so it should have pushed that. Well, let's check ICE and see if we see anything. TACX live logs. Nope, it's doing it. All right, so I missed it in there. But here we can see that switch is logging in via TACX and the DNAC user. What did I miss over here then? Because authentication login radius group. Nope, the server's there. So, okay. Not really sure why it called it. Oh, that's client. Oh, here it is for the VTY. Perfect. All right, that's what I missed. I was looking at the CTS list for TrustX stuff instead of the VTI or VTY. So we're good there. Now that we've got that provisioned, we can come back over and go to our fabric. And what we'll see in our fabric site is that our switch has now shown up and is available to us. Here he is. So if I click on this guy, I can see I can now assign fabric roles. Border node. Now here is where we get into that Fusion Transit and the Fusion Transit pool. When I enable a layer 3 handoff, I want my local autonomous number 64513 because my other one was 64512. Actually, I'm going to make this 17 because someone in lab 1 might use the next one up. Default. Now here, if I do add transit, Fusion Transit, here's where I would select that pool, and it will dynamically grab IPs from that pool to build the relevant interfaces and assign them. If I didn't want to do that, when I do an add interface, right, we're going to use 47. 48 is currently being used for our connectivity, but if I use 47, when I turn this on, I can assign VLANs and I can manually input these IP addresses. If I cancel here and I choose this pool and I come back down and choose 47 and I enable these, you'll notice I don't get the option to do that. It's going to automatically assign them. So here I have to choose VLANs, right? This is going to create VLAN sub-interfaces on the switch. We'll go look at them when it does. But here, if I do, we'll call this one 999 and this one 998. Save that. Add this. Now on the control plane side, right, this node is going to be both a border and control. One thing we've got to watch out for, obviously, list pub sub. Here we can't run that. Again, I mentioned earlier, limited feature set in the 3850s, has to be running 17.6 or later. Obviously, this switch doesn't do it, so we're going to go list BGP, add, deploy, apply, next, and we'll let it generate this config. And here's what we get. A whole slew of config. So lots of information. You can see it's pushing all our BGP information here. And I'm going to go ahead and deploy this. Over here again, if I go to my tasks, we'll see that this is running, and I'll pause till it finishes. Okay, it claims to have been done here. So now, if we go back over here and we click on this border node, we hit configure, we come down here and we click on our interface, we'll notice it assigned .1, .2, .5, and .6 as our interfaces. If we come back over to the switch and we log in, you can see that VLAN 998 and 999 got created respectively, and 998 is in the VRF forwarding field of dreams. It created that. 999 should be in the default VN or default VRF, and show run pipe section BGP. Here we've got all of this BGP information. So what I'll typically do at this point is I will grab, oh, it jumped in the middle of me here. Let me see if I can get it all in one shot. All of this, and we will pull it out to a notepad, and I'll start to modify it. 512, that doesn't matter. We'll leave that in here. This, of course, is going to be the opposite side, right? 517 for that guy. That will be fine. So that should match. If we look up at our interfaces again, it's going to peer to 5. I don't need any of these networks on the other side. We're redistributing our Lisp. We don't need that on the Fusion, obviously. And then here, this is going to go 5, 5, and 5. And then in our Field of Dreams VRF, again, we don't need any of the networks or aggregates or redistribute lists. There is none there. And here, 4517. And this is going to be 3, correct? Let's make sure. No, that is going to be 1. Good thing I looked. So this will be 1, 1, 1, and 1. And then if I look at show run int VLAN 999, 998, we grab these as well. Get rid of the fluff. This is going to be 6. Or is that going to be 4? Am I still messing this up? We're at 30s, so 4, 5. Nope, it's got to be 6. And this is going to be 2, given the WAC 30. And that should do that. So these are the interfaces and the VLANs that I'm going to create on my Fusion. DA, VLAN 998, VRF. Whoops, I can't do that. From Field of Dreams. So here, if we go back over to our router here, oops. And again, this is our Fusion. Make sure nobody created VLAN 998 and 999. We'll grab our config for the interfaces. They both came up. Obviously, our port 48 should be a trunk, so oops, 47. What am I thinking? Yep, all right. And then over here, we'll grab our other snippet of code for all of our BGP settings. And there we saw our neighbor come up with 5 and our neighbor come up with 1. So at this point, we've got our transit completely configured. Here, we should see our routes that we created. The Anycast gateways for are being advertised up here now. Likewise, we should be sending a default route down to the border node. Now, I don't think I did that here. So if we look here, show IP BGP, yeah, we are not learning a default route. So I need to go back up here, 64.512. Oh, I didn't create the VRF, therefore it didn't. I don't need to create the VRF. Never mind, this is on the Fusion. So address family IPv4. Now keep in mind here, right, what we've effectively done is merged those two VRFs, right? So if for some reason, going back into the network, your VN shouldn't be able to talk to other VNs, you would obviously have to handle the fusion accordingly as well to create the VRF and keep that traffic segregated. In my case, I don't really care. They're getting merged here, so to speak. Now did I do that in the wrong spot? No, I didn't. All right. So here we should be seeing a default route. I may have to redistribute static in order to get that to show up. Okay, so in order to get the default route, which in a normal environment you may or may not want, right? If you want your default route being advertised into the border, in that case, right, you have to make sure that it's coming from the fusion. So in my case, I obviously had to put, default information originate, but I also then had to add my network here for 000 to the BGP statement. My route here, just to kind of give you some background into the lab, this default route points at a FTD firewall. So in my case, I want that route to come into the fabric. So now here, if I look, show IP BGP, I can see I'm learning a default route here. And then if I look at the VRF, I'm learning a default route there. So now these guys obviously have their default route and our fabric should be complete. At this point, I should be able to take down that other link, right? And everything should continue to function. My current route is still being trumped by the static right there. But if I come in here and I do a default interface gigabit Ethernet 1048, no IP route, .0.0.0.0.0.0, just to clean this up. Not that it would make the table now, but now we'll notice our default routes from BGP. And we're missing something. Oh, we're not probably advertising our loopback to the border. Actually, no, it's not that. I need to clean this up on this side. So here, 1048, whoops. Here we need to get rid of that. So default interface 1048. Route. And here we need to get rid of this route. Not that it's going to make the table now, but still to clean up. And now we should see that we're learning our loopback via BGP. So over here, that should have fixed this issue, and it did. So now we're on the fabric completely. The next step, we need to bring up the other interface on the point-to-point link. So if I go back over to DNA Center, and here, all we're going to do is add another external interface, and in this case, it's going to be 48. And here we're going 997, 996, And this is going to create our new SVIs for the redundant link. And it failed. And this is actually another good piece of information to have. So I factory defaulted this interface on my border. However, DNAC has no idea that I'd done that. So in order for this to be successful, we're going to go to Provision Inventory, and we are going to resync device. And once this resync is done, we should know about that config change in DNAC, and everything will be fine. If I switch this to Provision instead of Inventory, there, I can see this is syncing. Once that gets done, we'll be right back. Okay, so now that's good there. It should know about the config change that I made local to the device, and we should be able to go back to our Fabric site and add that link now. $48, $997, $996. So it, of course, gives us all the information here. It's going to create the new VLANs, create the new SVIs, add those links to the BGP, and update some Lisp info. So we'll submit that. And then over here was our failure before. Now here we are again. So we'll let this finish. Okay, so it says it's successful here, and now if we go back to our switch, we should see and of course now we have to transfer this over to the Fusion router, just like we did with the other one to bring up BGP. So here we will get rid of all of this. 64.512. We don't need any of that anymore. It's already been there. Now here we need 14. We already had 6. Going to 64.517. That is good. We don't need any of this. Or 6. Just, whoops, this is actually going to go to, whoops, didn't mean to pull that out. Not 14, but this is going to go to 13 because it is going to be 14. So down here, this guy's going to be 14, and this guy's going to be 10. So this will be 13. And is that good there? Yep. Down here, get rid of all of this, and 2. This guy will be 9. 517. 9. 9. 9. Perfect. I can get rid of this stuff. Not even going to name those guys for right now, just to get through this. So now over here, I didn't notice this before, but obviously this VRF forwarding that I left in there failed, which I wanted it to anyway, but I didn't catch that before. And then we'll throw this in. And we should see these neighbors come up. Mine hasn't come up yet. Must have fat-fingered something there, didn't I? Six and 14. Oops, well, that's what I did wrong then. No, 10 and 9. Dug around and figured out the issue. I must have done something wrong here. 996 didn't get created. Probably fat-fingered that back over here. Oh yeah, I did 997 and 8. There we go. And there we have them all up. So now we are fully functional between our border and our edge. And, you know, just to reiterate, this has been the hardest part of this to wrap my mind around, is this connectivity between the fusion and the border node with the BGP, and of course what we have to do to bring it up without cutting ourselves off, and you know what routes need advertised manually from the fusion, that sort of stuff. But here we are now up and functional, and we should be ready to move on to the edge switches. So over here, if we look at our edge switch, we are not able to get out, albeit we are learning a default gateway from. So what we're seeing here is that those routes are not being redistributed into BGP, our ISIS underlay routes. So if I look at my BGP here that DNAC pushed, we can see here that that network is there, but the other ones are not. So I'm going to have to, of course, make sure that those get redistributed into BGP. They're not a part of Lisp, therefore they're not going to, you know, be with the rest of the Lisp networks. They are true underlay. So in here, I'm going to go ahead and add those manually and go from there. So config T router 64517. Oops. Now, I suppose I could choose to add the whole 10.197.0 network and force that to advertise, but we'll just do it this way for now. Whoops. Fingers don't want to work clearly. So now if we come back over to our Fusion, we can see all three of these, which should have fixed up that issue. Perfect. So again, I'm going to write this config here. And now I will want to go over to DNAC, and I want to resync that network or that router or that switch because I just made a change locally to it. That way DNAC knows about it. Not that it really matters at this point. If I try to add that device, 253, my DNAC credentials, my SNMP, my netconf port, validate. So that was successful. We'll add this. And as soon as this jumps away, we'll go ahead and add the other one as well. .252. I didn't validate that, I just added it. So hopefully everything was correct there. And we'll give this a couple of minutes. And now we can see both of these guys synced up. We can see them both. One thing we'll notice here, if I directly go over to my Fabric site and I jump in here, what we'll see is those don't show up yet, right? Again, everything is based on that hierarchy. So in here, if we check both of these guys, assign devices to site, here I can do multiples, so I'll just do them both at the same time. We'll say that they're in the same floor. And it gives us config previews of both of them. Take a minute for the other one here. But we can go ahead and deploy that. Of course, over here, that's going to kick off the process, and we'll pause till that finishes. And there we have that as success. So as we did with the other switch, we'll go back here, we will provision it. And again, I could have assigned it to the site as I provisioned it. I didn't have to do that in its own separate step, but I did. And here we go again. And we're ready to go. So we'll deploy this stuff. And back over to our tasks. We will refresh here and notice the provision running and wait till it finishes. Looks like based on my little orange dot here, it might be done. There we go. So now if we come back to our Fabric site, did not mean to go there. We'll notice we have our two switches here. It knows about their connectivity on both of the interfaces. And now all we need to do is say this is an edge node. This is an edge node. And deploy. And deploy. Now over here we should see we're modifying fabric, and we'll wait for that to finish. So here, that is successful now. If we come back over to our site, we can see these are edge nodes connected to our border, and that is going to do it for this video. So we now have a fully functioning fabric, and at this point, those that wireless access point and that phone that are connected to the edge switch are going to try to be connecting to the network now. They can't do anything yet, right? We haven't given them any sort of ICE authentication. I'm running closed mode, that type of stuff. So in the next video, we will be going in, configuring ICE, making sure that that wireless access point can get an IP address in the proper VLAN. We will configure the DHCP scope for that VLAN and make sure that it is set up to point to DNAC so that that AP can go through plug-and-play provisioning, along with a number of other things. Obviously, we have to configure the wireless controller and that type of stuff. So this will do it for this video, and we'll jump on to the next.